Okay, I think we can get started. Hello everyone. Welcome to this special lecture of the NCI-funded Big Data Training for Cancer Research workshop. My name is Min Zhang. I'm Professor of Statistics and Associate Director of Data Science at Purdue University Center for Cancer Research. So it's my great pleasure today to introduce our speaker, Dr. James Mohler. To keep my introduction short so you can hear more from Dr. Mohler, so I will highlight a few things and then hand it over to him. So Dr. Mohler has been at Purdue for over 33 years, first as an undergraduate student, then graduate student, faculty, and currently as an administrator. So he served as an associate dean for over 13 years. And starting his fourth year as Purdue's Research Integrity Officer. So it's really, Dr. Mohler has helped us to initiate this workshop, since day zero, basically when we submit our proposal. So something special about Dr. Mohler is that, he is celebrating 30 years of marriage this summer. Congratulations. So please join me in welcoming Dr. Mohler.
Thank you. And so as far as I know, it looks like somebody's sharing their screen right now. So what I'm going to do as far as the way I'm going to present, rather than sharing my screen, I'm going to do a Twitch style like this. So if you see my video screen, if you either go to speaker view, or if you can actually pin my video if you want to keep it from swapping from various people's things. So again, I appreciate the opportunity to kind of share. I will say I am not a cancer researcher, far from it. My background is in computer graphics, computing in general. As Min said, going on 4 years as the research integrity officer. And so this is a topic that I oftentimes talk about in a course that I teach. But I will also say, hopefully throughout this session, there'll also be times for people to participate and kind of share best practices. So I want to plant the seed now that there probably will be some time at the end. And what I would encourage you to do is be thinking about, if you were to think about your data practices, what are some of the most critical things that you do? And the reason that I say this is because I want to start off by saying that, record keeping and data management practices are oftentimes passively learned by all of us. Every semester when I teach the RCR course, I ask students, well, how many of you have actually had a training course in data management? I might have 1 in 30 who've actually had a course totally focused on this. And even when I ask for a show of hands of how many people have had any training in their lab, oftentimes it's very minimal. And so I think the reason, for whatever reason, I think we pick these things up as we go along, as we move from lab to lab or institution to institution. Hopefully we pick up some best practices, but there doesn't seem to be, at least in my mind, a single source that tells you all the best practices as it relates to data management and data record keeping practices. That's why I think it would probably be as beneficial. I can obviously talk about this topic for a while, but particularly when we get to the end of this, I would encourage everyone, I'd like to kind of open it up for discussion, about particular practices that everybody uses, because I find that that's one of the best ways to go about it. But nevertheless, so oftentimes when I talk about research data and data practices, I oftentimes like to start just talking about the characteristics of research data. And one of the things that I recognize is that we all use different forms of data, and oftentimes multi-forms. A lot of the work that I do in the computer graphics and the things that I've done in the past, most of what I've worked with are intangible data sources, whether it be numbers, images, video recordings, audio, and so forth. Recognizing cancer research, there's probably a lot of physical materials involved, and the particular challenges that go along with that. But one of the other things that I find that is oftentimes lacking is the connection between these two things. So not only do we have oftentimes poor practices as it maybe relates to either digital data or physical samples, it's kind of haphazard in the way that we create cross-referencing schemes, particularly for those that are working on numerous different types of research projects. And I guess hopefully maybe one thing that comes out of this, if anything, is maybe sparking some thoughts to all of the researchers on here of how you might better standardize your data management practices, your record keeping practices, and making sure that everybody in your labs, from trainees to graduate students to other staffers, that everybody's kind of on the same page. I will say because I'll say on the flip side of that, when I, as a research integrity officer, unfortunately have to go in and do the work that I'm called to do, oftentimes it becomes very apparent that there's much lacking in this area. Everything from a set of folks working in a single lab, throwing all the data in a single Google Drive folder, all kind of naming things the way they want to name them, to similar types of practices if I were to have to sequester physical samples from some kind of refrigerated source or so forth, and on all the various labeling schemes. So nevertheless, dealing with intangible and tangible data, we also have different states of data. And so it goes without saying, I suppose, that if we don't have standardized practices in the way that we work with tangible data, it should be no surprise that when we're talking about preliminary data versus intermediate data versus final data, or keeping track of measured data versus calculated, we're probably, I guess my experience has been, I think we're best at published versus unpublished, because so much rides on us publishing and making an impact from our work. But nevertheless, it's not just being able to have practices that support the types of data, but it's also the states of data that we're dealing with as well. And then also data transformations across them. So some things that I think about my experience in working as research integrity officer. These are kind of the things that I see, and these are, to me, the kind of the baseline things that I would hope folks, if you're not doing, would start doing. But one is having some kind of practice using bound data books, whether that's sequentially numbering the pages or using dates and so forth, making sure that everybody in your labs are aware that, having a spiral bound notebook and using tear sheets is not really acceptable. As far as that, because one of the things I found is that oftentimes even some of our newest researchers sometimes will make that mistake of trying to do tear sheets, and that kind of removes the forensic record, if you will, particularly when it comes to a research integrity matter. Being kind of meticulous in writing a complete description of activity, I think, is sometimes something that gets cheated, if you want to say that. I come from a programming background. And so one of the things that I know with programmers, as we're creating programming code, usually when time gets tight or we're running out of time, what ends up becoming lacking is the internal comments or the internal documentation in code. And if you've ever inherited code from someone and had to try to decipher how they were thinking and why they programmed something the way they did, the lack of comments can become problematic. Well, even more so in the types of research that we do, when we're not complete in the descriptions of our activities, or we use shorthand things that maybe are only common to ourselves as we're keeping track of those things. And so certainly writing a complete description, I think, is important. And if you use shorthand kinds of ways in your note-taking, making sure that you provide some sort of legend at the beginning of your note-taking devices to make sure that if someone were to inherit those things, they could actually translate what it is that you're saying. Recording directly in data books, I think each researcher that I've worked with or met have different standards of the kinds of books they like. And I didn't do this just because I was doing this talk today. These two books always lay here. So, I have some standard devices that I like to use as far as hardbound books for note-taking, and that's a carryover from my research days. So I think trying to adopt some standard, whatever that might be in your research lab, and making sure that everybody in the lab knows what that is. Now, the fact that I could pull up, I have notebooks all around me that's showing my slight office supply addiction, and that's a totally different talk than this one. But nevertheless, finding something that works in all of this, I think the most critical thing is for me to say to you is to find something that works for you, that you can at least tolerate, if not like. Because I guarantee you, if those two things aren't met, if it's at least not tolerable, or even better, if you don't like it, it's not going to stick. And I think that's one of the challenges with all these suggestions, is trying to mix and match those things that best match your working style and the type of work that you do, while maintaining some of the requirements that required items that we need to do. So if you notice errors, whether it be in a what I would say a data book or a methods book, or maybe you put those two things together in one, making sure that we never white out or black out an error. I always suggest that, a standard practice. And again, all of these things, those on this Zoom call, this might be some old hat for you, but my question is this old hat for everybody that's in your lab? In other words, is everybody in your lab familiar with these kinds of practices that you kind of take for granted? And I think oftentimes we kind of assume that people pick these things up, but that's not really how it happens. But so never why. One of the suggestions I have for errors is, and one recommendation I have is just to put a strike through it with a date. I would encourage, because I kind of making the assumption that many of you on this call are either researchers that are academics or researchers in business and industry. Nevertheless, I'm assuming many of you are principal investigators on research grants. And so one of the things I would encourage, because when I talk about whiting out or blacking out an error, or even just acknowledging an error, there are so many of our junior researchers in my space, it would be dealing with graduate students, but so many of them, they're afraid to even bring forth errors. And so I would encourage you to try to create an environment that fosters the ability that if somebody makes a mistake, yeah, they can come and bring it to you. And I know it's frustrating when they make mistakes, but nevertheless, creating an environment where errors and mistakes are not hidden. So I mentioned a data book versus a methods book, and it really depends upon your field as to and the projects, quite honestly. Some people are either by necessity or just by choice or preference, they'll keep a separate data book and a separate methods book. Others will actually intermesh those two things in different ways. As long as you have a strategy for that and it's well known in your lab as a standard, I suppose that works just fine. Keeping tangible, and since I'm talking with cancer researchers here, I assume there's plenty of tangible data. Figuring out some kind of cross-referencing scheme is really important. Going back to me as research integrity officer, if I have to go into an environment and sequester materials, I've seen a wide variety or lack thereof of cross-referencing schemes. But having some kind of standardized cross-referencing scheme is pretty important. Particularly, and I mentioned it about the Rio space, but it's also important as it relates to intellectual property or IP discoveries that might lead to patents or other kinds of things. And speaking of that, obviously, witnessing pages is important. And so hopefully you have some mechanism within your labs or in your institutions to make sure that those who are the genesis of a particular idea are able to do witnessing, such that when it comes to an intellectual, basically a patent application or other kinds of mechanisms, and the appropriate people get credited. Now, I put here electronic data as a challenge. I've got some, particularly towards the end of this talk, I have some suggested best practices. We're also going to talk about electronic lab notebooks a little bit, as that's starting to proliferate into lots of different labs. I'm not going to advocate any particular one, but I at least want to acknowledge some things relative to those, and we'll get to that here in a little bit. So these are some I would call baseline standards that I would hope as just kind of simple principles that everybody is implementing. Now, and I have a slide later on talking about data management kind of policies and procedures relative to at least the two major funders that I deal with, NSF and NIH. But data management has kind of become, has kind of come to the forefront as we recognize that the data that we generate in our research is can be as important as the actual publications, the actual research journal articles, and all those other kinds of things that we publish for impact. And so kind of acknowledge some of the main issues here in data management, just as kind of a level set activity. But when we deal with data management plans, these are the main data issues we deal with. One is responsibility and kind of understanding where the responsibility lies as far as stewarding that data, shepherding that data, storing that data, and all of those kinds of things. I know at my institution that generally falls with the principal investigator. Other institutions, they're depending on where you are, a lot of times it is the PI, but it's not always. So acknowledging where that responsibility lies, having specific data management plans, and there are a slew of different sites that you can go to, websites that provide different templates for data management plans. The only thing that I would caution, and I'm going to put, again, it's hard for me not to have my Rio glasses on, is being careful, because sometimes we kind of approach data management plans, the descriptions of facilities and those kinds of things as kind of boilerplate material. My experience with at least one federal sponsor is that they're kind of averse to really any boilerplate material. And what I mean by that is, let's say I'm a researcher and I'm putting together a grant, and I go out on, I know a colleague who wrote a really good data management plan. So I just take that data management plan, and in some cases, I may actually do some text recycling from that original data management plan, and then I add my own words in it. I'd be cautious about doing too many of those things when it's shared across individuals. If it's shared within a particular lab, usually not a problem. But we had a federal sponsor who actually flagged some text recycling that was in what I perceived to be boilerplate material relative to a data management plan. They called it plagiarism. And so I'd be cautious about that particular thing, as there's more and more sensitivity in both the two big ones that I deal with, NSF and NIH. There's a much greater sensitivity to research misconduct, particularly fabrication, falsification, plagiarism. So just be careful about recycling material like that, particularly from other people, I should say, or other grants that you've seen that have been successful and so forth. Records management, file management, and file naming. And I have some best practices on file naming and file management. And it's getting easier, but it's also getting more challenging. Electronic lab notebooks, a lot of the storage kinds of tools that we have that are cloud-based or whatever, whether you're talking about Amazon storage services, you're talking about OneDrive, you're talking about whatever, Box, Dropbox, you name them. While those things become easier, there are also some unique things that are challenging about them. And I kind of said tongue in cheek at the beginning of this talk that, one of the challenges that I have sometimes is going into a lab, having to do an investigation or sequester materials. And I find that everybody's got all their crap dumped in one box drive with little or no organization. And I would say, I'm an anally retentive OCD type A personality. So I'm the type of person who lives by lists. And even when I get a task done that's not on my list, I write it on my list just so I can check it off. Now, if you identify with that kind of behavior, organization is probably up your alley. But what I would say is, if you're the type of person who that is not your strength, that's okay. You can't become something you're not. But what I would suggest is getting someone on staff or tasking someone who really thrives on, that kind of behavior and that kind of regimen to help you structure and maintain and those kinds of things of files. To take a very creative personality who is not a list person and try to make them totally organized like a list person would be, just is not going to work. So rather than trying to bolster a weakness that you might have, instead, I would focus on your strengths and let others bolster those weaknesses. Hey, records management, metadata. I also have some suggestions for wrapping metadata around some of your files, or the data that you work with. Backup and security, and a big question there is how much institutional support you have. In some institutions, backup and security is kind of on you. And I have some best practices I'm going to provide here at the end of this talk, but try to I would encourage trying to take advantage of those resources that your institution provides. And those things, if they don't provide those things, then if it's not a strength of yours, again, task somebody with it in your research group who really kind of thrives on that. But the key I would say is when you go institution to institution, there's a wide variety of what level of support. Oftentimes when I'm talking with graduate students, I oftentimes recommend that, oftentimes when we talk to undergraduate students, we tell them to look at the total compensation package before they accept an offer and a job. Well, as a researcher, I would say look at the total compensation package, and part of that is what kind of institutional support you have. Who owns the IP if you leave? Can you take the grants with you from one institution? Who ends up owning the patents? Do you get to keep your scholarship? These are the kinds of things for researchers that we need to factor into our total compensation package because they affect us long term. So metadata, backup security, ownership and retention. I'll say at Purdue, Purdue is pretty generous with ownership and retention, and I'll talk about that. If you're unfamiliar with your institution's policies on ownership and those kinds of things, I'd take some time. And if you're planning to go to another institution, take time kind of looking into those things. Lastly, long-term planning is kind of a long-term sustainability, and it's not just about where the data lives, but it's in what format, and making it accessible and usable, particularly in these days of big data. As these data sets get larger and larger and larger and larger, sustainability is a huge issue. Again, as a cancer researcher, you may not be able to be an expert in the IT issues. And if it's up your alley and you want to focus on it, great. But instead, and I say this tongue in cheek, they give people degrees in that for a reason, rather than trying to do the things that you most, or that you can uniquely do, as opposed to trying to be the Jack or Jill of all trades. And I think that's one of the challenges we have as principal investigators, as researchers, as faculty, whatever word you want to use, is we can't be everything. And if we stick to our strengths rather than trying to be everything in every situation and then hiring those things out, I think we can be much more successful, because we just can't be a master of everything. So data management plans, here's kind of the data life cycle. And most good data management plans are going to address to some degree each of these things. Now, because I know probably what is most relevant to this group would be NIH data management plans. And I did find, as I was kind of preparing this morning, there are, and at the end, I do have a reference to what I think is a really good site for those who need to build NIH data management plans, because there is kind of a structure that you can use. So here are some things that I think cross both boundaries of NIH and NSF. Some of these I've already talked about in just general data management principles. Acknowledging the types of data that you're going to be working with, what we would call data type in computer program types of terms, but also what that research impact output comes from, how you're going to archive, store, data file formats. This list is kind of a repeat a little bit, but it's a little more specific. One thing that I didn't talk about before is kind of the legal and ethical restrictions on access and use, and making sure that you're abiding by that. And I'm not just talking about federal sponsor kinds of things. I'm also talking about things like HIPAA, which would be particularly relevant to this group. I would assume if you're an academic institution, there may be some FERPA types of things that you have to be concerned with too. But kind of addressing how you're going to deal with those kinds of things and how you're going to protect that. And this is particularly challenging as we use more and more cloud services, because what's happening is historically, research that was protected under ITAR or export control kinds of requirements, you had to be careful which cloud services you use, because you can't always guarantee that the servers are in the United States. Well, what I'm seeing happen with a lot of the research data in other that's beyond export control and stuff, there are more and more research, more and more the federal sponsors that are concerned with making sure that that data doesn't hit foreign servers. This has to do with the concept of undue foreign influence, which is huge in the cancer community. Hopefully you're abreast of that information. If you've never heard the term undue foreign influence, I would highly encourage educating yourself. Not what I was going to focus on today, but if If anybody wants it, I have a list of about 15 seminal sources that I can provide you to kind of read up on it. And these, when I say seminal, they are the federal sponsors like NIH, NSF, the DoD, the DOJ, the FBI, high-level U.S. federal government offices, and associated research groups that do work for the federal government at that level, making recommendations. This is a huge thing, and I don't see it going away. Not the topic of this talk, but I'll just throw it out there if anybody wants that list of items. So data sharing and access issues, we do have to deal with some of that. And I think I actually, now that I'm thinking about it, I think I have this slide repeated a little bit later. So talking about and discussing and knowing what kinds of things we can share, with whom we can share it. What's missing in this slide that I had added is also being aware of material transfer agreements, which I would think would be particularly relevant to this group. Also data transfer agreements. So essentially an MTA or a DTA, all it is a legal contract that says what you can do with the data, what you're licensed to do with that data. In some cases, it may actually tell you how you need to store it, how you need to transport it, and all those kinds of things. I would assume that most of you, because you being in cancer research, deal with materials that would fall under an MTA. I assume you're familiar with that. Just know that there's a counterpart to that, which would be a DTA or a data transfer agreement, which functions in a very similar way. I put on here at the bottom here some things that these are some things that we have to deal with at Purdue. So state open records statutes or FOIA requests, just knowing those kinds of things that you may be under the jurisdiction of or have to respond to. Oh, so some legal requirements. So just I would recognize that the federal sponsor has a legal right to audit and examine your records at any time. And I would assume all the institutions that are represented on this Zoom call also have a responsible conduct of research officer, a RIO, research integrity officer, some kind of compliance officer who would also have this kind of access. And typically the federal sponsors do work through, like at Purdue, they would work through me as the research integrity officer on this, or our sponsored program services arm, depending on, if they're looking at financial or other kinds of compliance issues, it would be SPS. If it's more of a research misconduct thing, it would be through me. And in my short time as research integrity officer and at Purdue, I will say I occasionally get the proverbial greeting card from NSF or NIH. Because essentially what they do is when there are research misconduct allegations, they kick it back to the institution to work through its process first, and then they follow on with a secondary process, as it were, after the institution does its. But so federal sponsors can come in at any time, and so it's critical to have detailed records. And I would say, again, we're in my RIO hat, particularly in cases of research misconduct, because although there's an assumption. There's an assumption of innocence going into that process. When it comes to the matter of determining culpability in a particular matter, honest error or negligence, which are kind of considered equal, which actually exonerates you from research misconduct, is oftentimes in the note-taking, it's in the documents, it's in the research record trail, that if you're going to be able to show honest error or negligence, it's going to be in that trail. So that's where this, writing complete descriptions, being meticulous is so important from the, protection of the negative side, which would be research misconduct allegations, but also from the positive side, if you're talking about, inventions. And so there's no hack for good note-taking. There's no shortcut. I mean, there are certain things that can make it a little bit faster, but at the end of the day, there's not really a great hack for just being meticulous. That I think is absolutely critical as it relates to research misconduct and inventions. Now, special requirements may apply to certain types of data. I've dealt with export controls on my side. Most of the research that I've done in the past would either be corporate work or NSF. So I have not as much experience with NIH, but so select agents, HIPAA, those kinds of things, which I've already mentioned, are things that I'm sure you are all sensitive to. Now, data ownership is something that when I'm talking with graduate students who eventually I hope will become PIs at institutions, wherever that might be, I always tell them that, it's critical that you take a look at what are the institution's policies on data ownership. And so I've kind of put what I've written here is really kind of Purdue's approach. And I think Purdue is pretty generous. And so Purdue generally looks at the principal investigator as the steward of the funds, of the integrity of the project, steward of the data. The PI is kind of the steward for data collection, recording, storage, retention, and disposal. Now, what I would say is it's kind of like at Purdue, the PI is kind of the Jack or Jill of all trades. They have to cover all those bases. In some institutions, the research work, these different responsibilities may be divvied up. If you have a large enough research group, you may want to look at, okay, which of these things am I as the PI strongest at that I should do, that only I can uniquely do? And what are the other things that I can have other individuals do under my guidance? Again, kind of focusing on a strengths-based model rather than trying to focus on improving your weaknesses. 10 hours spent improving your strength will gain you much more than 10 hours on some weakness. But data ownership. So now Purdue, and I guess I didn't finish my thought here. So Purdue, where this comes into play and usually comes into a question is when a faculty member leaves Purdue, can they take their data with them? Can they take their research with them? And Purdue generally, as long as you're leaving in good standing, Purdue generally will allow that to happen. Now, I don't know what the policy, procedure, or standpoint, philosophy, whatever is at your institution, but again, this is a big one to take a look at. I know I've met other researchers who've come to Purdue from other institutions who, because of non-disclosure agreements or other types of things, really have to restart totally once they come to Purdue. And there can be pluses and minuses across the board. I would just encourage being familiar with what the requirements are at your institution as far as data ownership is concerned. Now, data retention. So data retention relative to federally sponsored programs, 3 years, typically after the submission of the final expenditure. So that's key there. Human subjects, which is, I come more from the human subjects IRB kind of standpoint, which is also 3 years. Data supporting patent claims really has to be protected for the life of the patent plus 20 years. And other requirements for there are other requirements for special types of data. Here's the, and I hate to say this, I'm going to do something real quick because I want to check myself. I'm questioning whether this is the slide deck that I updated. Yeah, it is, I guess. So, all right, sorry for the sidetrack there. Too many files going on at the same time. So data sharing, this is the slide that I had said earlier that I thought was repeated, and I was correct that it is repeated. So let's switch back here to this. All right. So here's the interjected slide that has the material transfer agreement, just a duplicate, so I apologize for that. All right, so I want to note a couple differences that since I was less versed in the NIH coming into this talk, I spent some time this morning, a couple hours working on just kind of polishing this presentation and such. And I wanted to do kind of a comparison between NSF and NIH. And so first and foremost, coming from the NSF side, and there may be a few of you that maybe you delve into this a little bit, I don't know. NSF is basically a 2-page kind of data management plan. And so it can be a challenge. And there are compliance and sharing policies. More important, relative to NIH, they have a new, and one of the things I would acknowledge, and hopefully you're all familiar with this, is that they do have a new policy that's going to be effective or has to be in effect on January 1st, 2023. So there's time to do that. I did stumble across, and I thought it useful, that MIT has provided a summary, what I thought was a good summary. And it does look to be freely available, but a summary of kind of key points of differences. So I would suggest you may want to take a look at this. I think, if memory serves me correctly, this probably came about the same time. Yeah, so it was February when the NIH put out the new requirements for RCR, which are supposed to be in place for this fall. So our responsible conduct of training, responsible conduct of research training requirements. But nevertheless, and this slide deck I am providing to Min, and I sent it to her right before we started this. And I assume she can distribute to all of y'all so that you can actually have the links that are in here. And hopefully you'll find those useful. But I do want to acknowledge, I'm not going to dive into the summary of changes there that you can look at after the session is over. But nevertheless, I wanted to provide it. So now I want to kind of jump into kind of 3 best practices things. One is kind of best practices with file names. Second would be best practices with metadata. And then third is basically kind of storage kinds of things. And so these best practices, and I would encourage, if you don't have policies in your lab, in your institution, or whatever that's kind of driving these, I would encourage potentially thinking about it. So avoiding special characters in a file name, because when you go, it doesn't matter what system you're going across, these special characters oftentimes cause problems. It's particularly noticeable when you share things across the web, or if you try to create links with them, these special characters. And particularly leaving spaces out, using underscores instead of spaces is what I typically do. Now it says here, use capitals for underscores instead of periods or spaces. I typically use underscores for everything as a replacement value. But essentially what you want is no spaces in there whatsoever. Also, if you happen to be a person who works on a Mac versus a PC, you're always having to deal with file extension issues and being kind of attentive to that, because when you go from the Mac to the PC, the Mac file system basically has 3 parts to the file. There's the data part of the file, which is PC has that as an equivalent. You have the resource fork and the finder fork. And the finder fork and the resource fork don't exist on the PC necessarily, because the PC derives all of that by the extension of the file. That continues to be a problem. And so particularly if you're a Mac person, kind of being religious about file extensions. If you're on a PC, I would highly encourage making sure, because by default, the PC typically turns off file extensions. I would encourage turning that on so that you can actually see the extensions. And a lot of institutional policies have that turned off by default as well. And it just becomes a pain in the butt when you're trying to figure out what types of files things are, or if you're going cross-platform. Using 25 or fewer characters. This is basically because of limitations, both physical, human, logical limitations, but also software operating system kinds of limitations. Another going back to one of the other things that I will tell you is, if you go between Mac and PC, and I've seen this with data files, is be careful that you don't like if you copy a big data file, any file, copy it to a Mac partition on a USB drive or whatever, and then you take that USB drive to a PC. Oftentimes when you get to the PC, you'll see these extra things, particularly if you have hidden files turned on your PC, because you can turn that on off and on. I would encourage not deleting that, even though it's kind of, for PC users, it's kind of a pain, it's kind of annoying. Leave that stuff. Don't, because it'll make your transition between Mac and PC easier if you're working cross platforms with various people. So moving on. So using some documented and standard descriptive information about the project or experience in the file name, trying to make the file names descriptive of what they are. Now, that can be challenged with 25 characters, but you can also intermix that with folder structures, and trying to create some standardized way of creating folder structures, and just some simple things. Like, one approach is to, on folders, is to actually create or insert the date in some standardized way. And you can use the ISO 8601 standard, but having some kind of standard and organizing the folders by date. So like if we're talking about, what is today? Today is the 17th. So 05_17_22 _ then whatever the name is, because that makes it so that if you're looking at things in sequence, you can actually organize by file name or organize by date modified, and you can actually see things in order. Another thing that you can do is, when you're trying to order files, is and this is really critical. If you're going to have a set of files that's going to be less than 100 files, you can use 01, 02, 03, and so forth. or you can use 001, right? So this is where kind of being meticulous with file names can be incredibly important. So just having some kind of strategy for this rather than just letting things fall where they may and living life by default and just letting it happen, because doing that, and particularly, I see this a lot with extremely successful researchers where they've just kind of let that happen. And then they go back to try to find something and it's just impossible. It's impossible to make heads or tails out of it. So I would encourage creating some structure. And then lastly, including a version number. Now, if you're using like an electronic lab notebook, or if you're using something like the Open Science Framework kinds of things, versioning can actually be included with it. I would still be meticulous about including version numbers with files, and having some strategy for dealing with that. So these are some of what I think are the best practices relative to file names that I could think of and cobbled together from various sources that I found. And there may be additional ones out there as well, but that's at least that starting point. Relative to metadata. So metadata can either be a manual process, or sometimes it can be an automated process from various software tools that you're using. So I'm thinking about this. When I wrote this, I kind of wrote it as from my programmer brain, if you will. But having some kind of data dictionary is absolutely critical, particularly with abbreviations and metadata. There are certain standards, or there are standards that you can use to structure or guide your metadata. And there are numerous ones, and I'm not going to get into all of them. Making sure that the metadata describe the content of the data files. And I kind of look at metadata like I look at programming code, like comments in programming code or internal documentation in programming code, but making sure that that they're described. And let me go one step further. If you are working, because I'm kind of theorizing here. I mean, if you're a cancer researcher, I assume you may be working with IT folk. Maybe you're not the IT expert, but you're working with IT folks. Share some of this with them because they'll understand it. And more importantly, require that they do some of these things. Because what IT folk oftentimes will do is they cut corners. I worked in our central IT office for 2.5 years. I basically trained programmers in the early days of my faculty life. And so I know how they think and I know how they behave. And so if you make it a requirement that they do these things, it's much more likely to happen. Because one of the things that can be a challenge is IT folk are transient. And nothing's worse than to lose your right-hand IT person and then have to basically indoctrinate a new one or train a new one to do things the way you want, but you have no framework, you have no comments, you have nothing that describes what the past person did or how they did it. And so to me, the problem, and this is my where I think things are going. The problem that we have today is managing data. And that is changing that data into knowledge, into something that can be applied, that can be used in some way, that can be made sense of. I think the problem in 10 years is no longer going to be a data problem. I think the problem is going to be all of the code, all of the programming, all of the tools that we trying to wrangle those. So it's no longer about wrangling the data, it's about wrangling the things that wrangle the data. I think that's the future problem. And so anything you can do to get your arms around that ahead of the curve, I think will be important. Anyway, I got off the track there, but define parameters and the units on that parameter. Again, it's the way in which you're describing the chunks of the metadata. Explain the formats for dates, time, geographic coordinates, and other parameters that might be in your data. The way I would think about this is, if you think about an Excel spreadsheet with each column representing something, and you can go into the Excel spreadsheet and you could say, okay, this is going to be date format, and this is going to be dollars, currency. This is going to be essentially, this is describing essentially the fact that you're setting that column to this and that column to this and that column to this. This explains in the metadata, this explain formats for dates, time, geographic coordinates, and other parameters. This is what defines that. Define any coded values, and particularly we're working with big data, and me not being a cancer researcher, I would say defining coded values that you assume people know what they are. It may be a certain ribosome type. It may be this, and I don't know all the scientific terms, but acronyms particularly, as well as things that may not be or that you assume to be standard. And you can really kind of have to think about it like a newbie. You have to think about it, okay, someone who doesn't know this data, will they be able to make sense of it? So describing coded values, describing quality flags or qualifying values, because oftentimes in our data files, we have thresholds or cutoffs or those kinds of things. And essentially that's the quality flags or qualifying values. And then lastly, I would say define missing values or how you have substituted for those missing values if you've done so. And so really, and I could go on with other types of things relative to metadata, but this is kind of a quick list of things that I think should be looked at. So best practices for backup and security. This is kind of the last best practices. So we're here in a few minutes, we're going to be to the section where I'd like to hopefully open it up for discussion to kind of talk about what are some key things that, what I would say, I'm going to seed the thought while I'm finishing up this. As I said in the beginning, what are some critical practices that you have relative to data and data management? The second thing I would say is, particular problems that you have, like something you're struggling with right now, like something that's not working the way you want it to work. And so those are the two things that I'd like to pose, because I probably have about 10 minutes, 15 minutes more of presentation, and then we can use the remaining time, because I think we'll have a half an hour after that for any questions, but also for kind of maybe some brainstorming. So back to the slide. So best practices on backup and security: make 3 copies. Having your original, having an external but local copy, now like on a USB drive, assuming it doesn't have protected data on it. I mean, you could put protected data on a USB stick or whatever, as long as you have it locked up somewhere. And then external remote would be the third, right? So those are kind of the 3 things. And most of this I'm talking about digital data, obviously. Having things geographically distributed, like local versus remote. So like on your local machine, as opposed to maybe in Box or OneDrive or whatever. Using a hard drive. I still like external hard drives for storage of large things as a secondary storage. Obviously USB sticks because of the size of them, but it really depends upon the size of data you're dealing with. And a lot of times in big data, you're still not going to have a USB stick that can accommodate some of your big data files, just not gonna. And so hard drives are still, and rather than spinny disks, it would be better to have, memory that's basically something that's non-mechanical. But still, if spinny disks is all you got, use them. I still have a couple spinny disks that I use in the office for RCR stuff. So use what you have available. Cloud storage. So I give you some examples of private sector storage resources. Again, the biggest challenge with those is just making sure that there's no problem with the location of servers and those kinds of things. If that's there, and there are cloud-based services that do offer US only kinds of storage, but nevertheless, just recognizing that. Unencrypted is ideal for your database. So encrypted versus unencrypted, do you store your data in an encrypted way or not? But unencrypted storage is ideal because it's easily read by you and other people in the future. You don't have to worry about it being encoded. But if you do need to encrypt because of human subjects or other kinds of concerns, keep passwords and keys on paper. Have 2 copies, preferably in a safe or locked somewhere, and then what we would call pretty good privacy encrypted digital file of some sort, and those kinds of things. Uncompressed is also ideal for storage, but if you need to compress, limit compression to your 3rd backup copy. So I would if you can, keep uncompressed, unencrypted, and encrypted, right? So that they're not all encrypted. So if something became corrupt, because when we encrypt it, when we encode a file, if we zip it, if we tar it, or we compress it in whatever way you want to talk about, what we have a tendency to do is to copy that file. And if there's corruption in one file, it ends up usually spreading to the others because of our copying practices. So just be careful with that. So there's some straightforward backup copy security things. And I put this in here, I just call it odds and ends. More and more people are using electronic lab notebooks. I know at Purdue, we have some, it's not consistent. We have not, as an institution, chosen a single tool to be used. I know, and I'm not even sure what all tools are being used at Purdue because we're so, we're a loosely federated entity, and pretty much each researcher can do what they want to in their own research lab as it relates to some of these things. But I would encourage you that as we get into managing and wrangling more and more digital data, you might want to do a little bit of a look at electronic lab notebooks. I did stumble across this kind of nice, I'm not a big fan of Wikipedia, but sometimes it's useful. There's this whole long list of electronic lab notebook software packages. Some of the one that sticks out to me is Lab Archives. I don't have any stock in it or anything. I'm just saying that's one that stands out. Open Science Framework, which I reference as well. And this may be a question, or this may be something where people on here want to share what tool you're using. And I don't know if a lot of times there's not a lot of connection across the country in this space as far as what tools people are using, that kind of stuff. And that might be a good conversation to have as well. The last point of note that I would make here is about the Open Science Framework. It is a free or open source web application tool. And MIT had the best description that I could find about the tool itself. So if you really want to dig into it, I know at Purdue, this is just beginning as a conversation. Our libraries folks, that was actually a question that was posed, I think back in January by one of our researchers who went up to a dean, and then there's some conversation about Purdue looking to get involved with the Open Science Framework. And really the question was surrounding reproducibility and how to improve reproducibility. But obviously there's a whole slew of other benefits that come if we start using Open Science Framework tools and so forth. So you may want to take a look at those two things. I did put on here some resources, and I don't know how many. I would look at your institution. Purdue has a research repository. Our vice president for research office does provide some suggestions. Most institutions do. And then here are 3 other sources that I found that I thought pretty useful. Even though they're somewhat dated, I still think they're useful and still applicable. And then early on, I mentioned the ORI information that I put out there. And so I put that link there as well. All right, so with that's kind of the presentation, man. I'm not sure if I hit what you wanted me to hit, but I hope I did. I guess first, if I'd be open to entertaining any questions, but we could also have some conversations about particular things, and there's basically 3 questions that I think come to mind. One is, and I just lost them. One is basically which tool you're using, which tools you're using potentially as far as electronic lab notebooks, what particular problems you're having, and then I'm doing these in reverse order because they're coming to my mind that way. The first one I would ask is, just what are critical things that you would recommend or share with your colleagues if you had to pick one practice that has made the biggest impact in your research group? What is it? So anyway, we can start with questions first since I'm asking questions.
Great, thank you. So I have one question to sort of kick it off. So I know at Purdue and elsewhere, as you mentioned, like a lot of groups use boilerplate. A lot of the cores, for example, use boilerplate rather than typing up a new data management plan or some other sort of informational document for each grant. So for the attendees in this class, should they, if they receive such boilerplate text from a group that's going to be collaborating with them, say like a proteomics core or something like that, when they're putting their grant in, should they request that the core alter the text or reword the text, since that boilerplate is going to be shared with presumably everybody on campus who wants to use the core?
So I think if you're in a research lab and you create your first original data management plan kind of from scratch, reusing that over and over within your research group is fine, right? So that's not a problem. If you did that and you connected with another university and you collaborated on a grant and you used what you originally created for boilerplate, that would be okay because now you're co-authors. Then this other group can now use that because you were co-authors. It's when you maybe go to a conference and somebody shares a data management plan that was, very laudable, or, maybe it was commented, oh, this is just great by the NSF or NIH folks. And you just reuse that without reference or citation. That's where it becomes a problem. I was really surprised in the particular situation we had that the federal sponsor was saying, and actually the faculty that reviewed it, like the investigation committee, basically noted that they were surprised that such boilerplate material would be considered potential plagiarism. So you just have to be careful. I guess I would just be cautious about that and know the federal sponsors are really much more sensitive to this than they have been in the past. I'm just being honest and saying at Purdue, we've seen a rise in research misconduct allegations. And I know we're not alone. In my Rio colleagues across the nation, they're observing the same thing. And I don't know what I think it's multiple things. Part of it, I do think it's the federal sponsors being more sensitive to this, but there are other factors too. But hopefully, Nadia, I answered your question.
Yeah, thank you. Thank you so much. Any other questions or comments? I do see one comment. Someone mentioned that they use lab archives.
I'm just curious, on a scale of 1 to 10 with of attention, where 1 is you're watching Netflix and only half paying attention to this, and 10 is you're just gripped by this. If everybody could give me a 10 real quick and type into the chat, and just what tools do you use? And nothing is an option too, because I do know there are institutions that are not using electronic lab notebooks for a variety of reasons, but feel free to type that in the chat just so your colleagues, because I'm not sure if everybody can see that or not, but we can kind of report on. I guess if I would have been thinking, we could have created a poll to ask this question. Here's another lab archives. Well, we got a few responses there. There's a comment here, because the ones that go just to hosted panelists, I assume everybody can't see. So a comment here, sometimes electronic notebooks can be a hassle, particularly on the bench or in the field or wherever you might be doing research. So old school can often be kind of just the way you go. And so I can totally understand that. Looks like lab archives, some OneNotes and storage stuff. So there's a variety of approaches here. So I'm curious, does this group, would the majority of this group have like a conference or something where these kind of tools are demoed and those kinds of things? And I do see the there was one open question in the chat. I'll answer that here in just a second. Or while people are doing it, I could go ahead and answer. So how I got into this line of work, it's kind of interesting. So I'm a faculty member in computer graphics. And so in the early days, I taught a variety of things, most importantly, Photoshop. And so I understand forensic imagery. And so was a faculty member, then got into administration. I worked my way up into an associate dean in the graduate school position. And quite honestly, we had our prior Rio, and he was the Rio before it even had a name. He retired and they needed somebody to teach the RCR courses. And so I decided to do that. So I taught the responsible conduct of research courses for about 2 to 4 years before the Rio position became open. And then once Rio came open, I enjoyed the content and applied for it and got it. So I didn't have a legal background. However, as crazy as it might sound at 50 years old in the fall, I'm starting a law degree just for kicks. And that sounds like a strange sadistic thing to do for fun, but I'm going to work on a JD in the fall and we'll see how that goes. So, and I don't know the court person who asked the question, I don't know that there's one path to this. The Rios that I meet from across the United States, they all kind of get into this in different ways. Some come from a legal background, some come from content specific areas. But it's been an interesting journey. So, oh, and I appreciate all the congrats and stuff. So what are good methods to standardize data ingestion, the first few steps of cleaning data so that they could be recapitulated, and if the original data updated, repeated? Is Jupyter Notebook a good way? What if our code changes? How do you keep the code and input together? One of the things, I'm going to throw this to the room rather than me, because I know there's a lot of knowledge in this room. So if you have thoughts on this, because I don't do this kind of research work, so it's really kind of hard for me to comment on that. So feel free to turn your mic on and jump into the fray here.
I will say that for me, containers are a good way to standardize work, is creating like a container of all, basically an app of your workflow, so that regardless of operating system, it can be run and use the same versions and everything. But additionally, one of the things that I do is I use GitHub a lot, and I will, I keep, it's a version control system, so you can keep track of all the versions and changes that you make to this code. And then I will submit it to someplace, like there's a Zenodo, and I'll put it in the chat, which basically provides Zenodo, it provides a DOI, like it provides basically a stable version of your code that was used for your publication. And so anyone who looks at that publication, even if you change your code in the future, will know that this is the version of the code that was used to generate every single thing you did in the paper.
So I know what it is, but I'm going to ask you, because you use the acronym. What's a DOI?
I don't know what it stands for.
It's a document object indicator, or document object identifier. It creates it, as you describe it, it creates an instance in time capture of something. It's kind of like the equivalent of an ISBN number, but for all things electronic data, right? It was originally envisioned as a way to identify original publications, like an ISBN represents original books. But now it's expanded to include, just as you describe, kind of a back-end support, so that you have a static capture of what was used to actually generate that result.
And then I had a follow-up question. How do you create a container, and is this a good system as we work on our group projects? Creating containers is done with like Singularity or Docker, and that's like an entire, we'd probably want to spend a good 3 to 5 days on just that. So I would not recommend you worry about this at all for your projects. And I think just in the future, when I started coding, I kept track of everything in a Word document because I didn't know what else to do. I was just getting started. And I think the important thing is Now I use GitHub, but which is a good way to do it. But basically just keep track of all of the changes you make and make sure when you publish that someone else could pick up your code and actually rerun it and get the same results as you. So.
Thank you for answering that, because I could not have said all that. So
no, you're fine. Let's see. And then John had mentioned to raise your hand if you would like to have your microphone turned on, and we can unmute you.
So maybe Nadia, I think most of our audience here have worked with their core, like bioinformatics core or biostat core for their data analysis. So maybe do you want to share some of your experience, like in terms of data handling between, say, the client's data, like how you handle that in the core, like kind of transfer back and forth while keeping the, especially if the data is HIPAA protected?
Yeah. So the bulk of what we work with is not HIPAA protected data, actually. And so actually Purdue doesn't even have servers right now to handle HIPAA protected data unless you're in an individual lab. And so the HIPAA data we've worked with has been all on the cloud. But generally, I mean, we will, it's preferable for people to give us the raw data as soon as they get it. And we kind of do all the data management with that data. We will analyze the data, and then we will submit the data to GEO and the short read archive. So it's publicly available. Upon publication, we embargo it until the paper is accepted and then release the data. So we sort of do all the different parts of that for the researchers. So we don't want to assume that the groups we're working with are keeping good track of all their files and are going to be keeping track of everything we tell them. So we sort of do that automatically so that we don't end up in a situation where we gave someone their data and they don't know where the hard drive is, or, and now we can't publish the paper because it was, we need to submit the data because it was funded by NIH, and, we have to submit it to the public domain or something like that. And so, so that's sort of how we take care of it. I know, Wenpin, did you have your hand up? Oh, her mic isn't, their mic isn't working. Okay. I think the mic isn't working. Do you want to just type it in the chat then?
Well, we are waiting. So, Jamie, I have a question for you. So, like, I think most of us here, like, really working on the, submit more like NIH proposal, and with the big data, as the data getting larger and larger in terms of the size and and the metadata. So, how do you feel like the data management plan, like in terms of the like know if there's if you start something like brand new, there's nothing to follow. What would you suggest to start with?
Well, I guess if you're starting from scratch with a data management plan, I would use, and there was this morning when I was looking, I found there NIH does provide like a document to begin, like something that you could start from, or at least the major sections that need to be there for sure. And that's kind of the best that I know. And I guess I would throw it out to anybody else who has thoughts on, how you get started in that. But that was the best thing that I used. I know when I was doing, I was, I guess I was in the NSF space when NSF actually started making data management plans required, right? So I kind of remember the starting from scratch. And so for some researchers, it's relatively easy because you started when it began and you've kind of evolved with it. But now, if you're just jumping in fresh, it's not to say that you can't use the data management plans from other people as models. You just can't lift word for word, or you have to watch the number of text, how much text overlap there is there. So certainly I think it doesn't hurt to have examples from other researchers. And a lot of times when I'm working with graduate students or even postdocs, one of the things I tell them is, as much as you can, while you're a graduate student or a postdoc, get examples of grants that your PI or your major professor have written, so you have examples to look at. Because too often I see graduate students just kind of float along and they do the bench work or the lab work or the research work, but they don't gather, they don't absorb that knowledge while they're going through it too. So I guess that would be, use NIH resources, and then also any examples that you have from other people. Just be careful lifting word for word from any particular source. That's the key.
Okay, thank you.
And we have some comments and a question in the chat. So when Pin had said she always asked the collaborator to send de-identified data, that way they don't need to worry about HIPAA, and generally uses the PI's name as the top level folder and each of the projects as a subfolder. Oh, wait, let's see. Oh, yeah. Okay. So let's see, this is a separate comment. They use the PI's name as a top level folder and each project as a subfolder, and keeps all the program codes in the associated task. And then the program version is associated and can be matched with each report version. And then we have a question. So how do you manage the NIH requirement to share data against the risk that your data can be used to create a genome that would allow an individual to be identified, thus breaching confidentiality? So I don't know if Dr. Mohler or Min, if you want to answer this, or.
This is not one I've specifically dealt with.
So I know from my end, I mean, if you're working with like genome sequencing, for example, or even a lot of RNA sequencing projects, you could submit the sequence data to dbGaP, which is maintained by NCBI, and it's private. So it's restricted access. And so that will restrict the data use to only folks who apply and basically have the setup for HIPAA regulated data, for basically identifiable data. And a way you can kind of get around this and still share the data widely that can't be traced back to the individual is that you can publish the count matrix. So just with the genes in the rows and the samples, of course, de-identified sample names as the columns. And that way, anyone who's interested has access to the process data, but they can't recapitulate the genome and gain access to information that could, in theory, allow you to identify a person. And the same goes for, single cell RNA sequencing. You can just publish, basically widely publish the process data without worrying about it. And then be very careful about where you submit your identifiable data to. So a lot of times, like if you're working with cell lines or something, this isn't as much of an issue. You don't generally have to worry about stuff like this. Or, obviously mouse, rat, canine. But if you're working with patient data, that's a good way to go.
Yeah, this also reminded me it's about 16 years ago when we first kind of worked with the GWAS data using the SNPs as as predictors, and then So somehow at that time, the data was still kind of free, and then somebody realized, oh, they only use part of the SNP data. The coverage was not that high at that time, so they already, like, I think 500K was the most, was the largest number. Mostly it's much smaller than this, but people can recover the genome and actually identify a specific person. And during the course of the project, they suddenly said, oh no, we have to put all the data into dbGaP, and you cannot have free access to it. And that's when we started to apply for dbGaP data access. And when we prepare for this big data workshop, we try to find the data for case studies. And then I consulted the NIH people, and they said, no, you cannot use the dbGaP data because it is kind of, you do need to have access for every single participants, which basically is not doable just because the confidentiality issue. So I guess, later on in week 2, you will see the data we use. So it's very, very few like genomic data, the DNA data available. And even if it is, it's very restrictive, especially for cancer. So we kind of end up with not a big data set, but that's all, like almost the only data we can find that public available.
Are there any other questions, comments? Yeah, you can also get permission from the patient to publish, which one attendee has done for a case report, and the patient was okay with it, and they got the appropriate forms from their research office. So I know I've worked with some patient samples where the patients did okay. It was like a tissue repository that their tissues were put in. And so that was not actually covered by HIPAA. So.
And I would say, oftentimes I would say, don't discount just asking. Don't be afraid to ask. I think that's an important point, because oftentimes people, if they think it might better someone else's life or improve, most people are willing to share. Somebody just the comment can even ask the next of kin posthumously. So any other questions or comments?
Okay, so if not, maybe let's thank Dr. Mohler for the wonderful talk again. So this is year 3 already. And yeah, I really appreciate all your great support for all the years, actually, even before this. And yeah, I'm sure I will ask you back next year again.
Thank you so much.
You.
Well, thank you so much for having me. And I applaud all of you for the important work that you're doing. So thank you for having me.
Thanks.